Okay, so today I'm going to be talking about oxygen and its effect on bacterial growth. I'm going to be talking about bacteria's relationship with oxygen. I kind of drew out what it will look like in a test tube, and then I am also going to be talking about how oxygen is actually toxic to bacteria and what bacteria use to kind of detoxify the negative effects of oxygen. So the first thing that I want to talk about is the fact that bacteria are split up into five kind of categories based off of their relationship with oxygen and how they tolerate it. So, obligate aerobes are oxygen that they require oxygen. I'm sorry, there are bacteria that require oxygen for growth. They are using oxygen as the final acceptor within aerobic respiration. I don't know if you guys watched my electron transport chain video, but as you know, if you watched it, oxygen is actually the final acceptor within that. So obligate aerobes cannot grow without oxygen. An example of this is tuberculosis. So Mycobacterium tuberculosis is a bacteria that grows and affects your lungs. As you know, there's a lot of oxygen within your lungs, so tuberculosis is going to thrive in that environment because it is an obligate aerobe. There's plenty of oxygen to go around. So it's going to grow very rapidly and quickly within your lungs due to that reason. The next thing are obligate anaerobes. So obligate anaerobes are bacteria that cannot survive in oxygen. It's toxic to them due to the fact that they lack the enzymes required to detoxify the negative effects of oxygen, which I will again talk about in a second. So they can't grow in oxygen. They can only grow in environments completely free of oxygen. An example of this is Clostridium botulinum. Botulinum is typically a bacteria that will grow in canned foods and stuff like that, places where there's no real oxygen present. So obligate anaerobes cannot use oxygen. Obligate anaerobes need oxygen. The other thing are facultative anaerobes. So facultative anaerobes are bacteria that can grow with or without oxygen, but grow best when oxygen is present. So they use aerobic respiration when oxygen is available, but they will switch to anaerobic or fermentation when oxygen is not present. An example of this is E. coli. The next kind of category we have are aerotolerant anaerobes. So aerotolerant anaerobes are bacteria that they don't use oxygen, but they are not harmed by oxygen. So obligate anaerobes are bacteria that don't use oxygen, but it's also harming them. It's toxic to them. But aerotolerant anaerobes are not harmed by oxygen, but they don't use oxygen. So they only rely on fermentation. Fermentation is the opposite of aerobic respiration. I'm trying to remember my example. Oh yeah, so aerotolerant anaerobes are mainly, a good example of aerotolerant anaerobes are the lactobacillus species. I don't know if lacto sounds similar, but lactic acid. Those are actually bacteria that are producing lactic acid, which is keeping the vagina at a low pH. So I talked about the vagina a little bit in my pH video. But the vagina usually sits at a pH of around 3.5 to 4.5, and this creates an acidic environment that protects against pathogens and whatnot. But lactobacillus, that species, are aerotolerant anaerobes. Because the vagina is not completely free of oxygen, there's still some oxygen in there. They're going to be the bacteria that is actually going to be thriving in that condition. So aerotolerant anaerobes, you're doing a great job most of the time. The other category are microaerophiles. So microaerophiles are bacteria that require oxygen but at very low concentrations. So at higher concentrations, it is toxic to them. At lower concentrations, they are able to survive. they lack some of the detoxifying enzymes that are actually neutralizing the negative effects of oxygen. So they need oxygen, but at a very low amount. So they're kind of in the middle there, and I'll show you what that looks like in a second. So what I have here, I'm sure you've seen this before, but these are test tubes. So obligate aerobes, you can see, are growing at the top of the test tube because the oxygen, there's a higher concentration of oxygen towards the top of the tube. So obligate aerobes are going to grow there and they're going to stay there. Whereas obligate anaerobes are going to be all the way at the bottom of the tube sitting there because there is low oxygen. The concentration of oxygen is lower compared to up top. Facultative anaerobes, you can see, are kind of mainly at the top, but they can also kind of float around near the bottom. This is due to the fact that they can grow with or without oxygen, but they prefer oxygen, so that's why most of them are at the top. Aerotolerant anaerobes, again, it's in the name, they tolerate oxygen, but they don't actually require oxygen. So they're kind of just scattered out, doing whatever they want. They don't really care. They're just all over the tube, right? Microaerophiles, again, because they require a low concentration of oxygen. Too high of a concentration of oxygen is toxic to them. Where is there a high concentration of oxygen? Near the top of the test tube. Where is there no oxygen? At the low test tube. I don't know if you can hear that. Hopefully you can. But so that's why they're kind of in the middle there, because there is just the right amount of oxygen between high and low. Okay, so the other thing that I'm going to talk about is how oxygen is actually toxic. So oxygen is naturally toxic to a lot of these bacteria, but they produce enzymes to detoxify the effects of oxygen. So I've said that many times throughout this video, so I'll kind of get into what that means. So oxygen produces what is called free radicals. So that's actually what is toxic to bacteria, these bacteria. So the free radicals are superoxide radical, hydroxyl radical, and singlet oxygen. Those are the free radicals. Now, what is actually going to counteract that? Catalase, superoxide dismutase, and peroxidase, hydrogen peroxide. So these enzymes are going to actually, sorry, I thought I heard something. These enzymes are actually going to, fight against, counteract these free radicals, and it's going to allow the bacteria to survive. So obligate aerobes have these enzymes. Facultative anaerobes have these enzymes. Microaerophiles, right here, kind of have these enzymes. Not really. Aerotolerant, sure, they might have these enzymes. And then, what did I miss? Obligate anaerobes do not have these enzymes. So that's mainly that's kind of the only thing. Sorry, I lost my train of thought. So that is essentially how oxygen is affecting bacteria. So remember these 5 kind of categories, because that will definitely be on the exam. Definitely look at these pictures here. You can find these online. That's where I found them. And that will also definitely be an exam question. But